In this video, we're going to talk about the bonding spectrum, or how electronegativity is related to what type of bond is created between two atoms. And let's start with a nonpolar covalent bond right here. Remember that electronegativity is the tendency of an atom to hang on to its electrons. So a more electronegative atom is going to hang on to its electrons more tightly than a less electronegative atom. And if we look at the electronegativity of chlorine, let's find that right here. We can find that number right here, 3.0. And to determine what type of bond it's going to make, we're going to subtract the electronegativity of one atom from the other. And if we look at chlorine and chlorine, if two chlorine atoms are being bonded together, we would subtract 3.0 from 3.0. This gives us a nonpolar covalent bond. This means that the electrons are being equally shared. If you look at this atom right here, the chlorine and the chlorine, their electronegativities are going to be about the same, or exactly the same in fact, and so they're going to hang on to those electrons, those valence electrons, equally tight. So those electrons are going to be shared equally. They're going to be spending the same amount of time around either of the chlorines, and so it's equal sharing. If we look at the spectrum between 0.5 and 2.0, we have polar covalent bonds. This is called uneven sharing. This is when one of the atoms have a greater electronegativity than the other. So if we look at oxygen and hydrogen, oxygen has an electronegativity of 3.5 and hydrogen has 2.1. And so if we subtract the hydrogen from the oxygen, it's going to give us 1.4, and that puts us right here in the polar covalent range. Now this is important as we learn about water, because water is a polar molecule. Because the oxygen has a greater affinity for those electrons, it's going to attract those electrons more often. So those electrons are going to spend more time around oxygen than it will hydrogen. Because electrons are negatively charged, it's going to give this oxygen a slightly negative charge. And because they're not spending much time around hydrogen, hydrogen is going to be slightly positively charged. And so a water molecule, or a polar molecule, any polar molecule, is going to have a positive side and a negative side, because the electronegativity of one molecule pulls the electrons to one side more. Finally, let's look at our ionic bonds. Ionic bonds are between two atoms that have vastly different electronegativities. So let's look at table salt, NaCl, or sodium chloride. Now, sodium is going to have a 0.9 electronegativity, and chlorine is going to have 3.0. Let's look at this on our periodic table. Chlorine has 3.0, and sodium has 0.9. Now, because the chlorine has such a greater affinity for the electrons, it's just going to steal it. It's going to grab it from the sodium, and so we're going to have two ions. Because sodium no longer has an electron, it's lost its negative charge, it's going to become a positive ion, or a positive 1 ion. And because chlorine now has an extra electron, it's going to be a little bit more negative. It's going to be a negative ion. And so when you have something that's positive near something that's negative, they're going to attract. So our positive and negative charges attract. And then the whole molecule together has no charge. Well, there is still a positive side and a negative side. The molecule in its entirety does not have a charge. We look at structures like salt that have crystalline structure. These are materials that have a ionically bonded atomic structure. So things with crystalline structure are going to be ionically bonded. I hope this helps, and please make sure you swing by to ask questions if you have questions.